We tend to think of scientific laws as permanent, unchanging rules of the universe, carved in stone. But in marketing and the social sciences, treating a law as a static truth is a trap. This diagram outlines the first major boundary of a law's validity, how it handles the variable of time. Depending on how a law interacts with that dimension, it falls into one of four distinct categories. At the base are equilibrium laws, relationships that hold only when a system is at rest. However, Shelby Hunt's resource advantage theory describes competition as a constant evolutionary struggle where firms innovate to leapfrog one another. Because this process is never-ending, the at-rest conditions required for an equilibrium law are rarely found in a functioning market. Moving up, we find laws of atemporal coexistence. These describe variables that appear together at the same time, much like a cross-sectional snapshot. The danger here is that researchers often observe these simultaneous variables and treat a single moment in time as definitive proof of cause and effect. Then we reach laws of succession. These actually account for the sequence of events, allowing us to predict that a specific state today will be followed by a specific new state tomorrow. Finally, at the top are process laws. These are fully time-reversible, meaning if you know the variables, you can both predict the future and calculate the past. While common in Newtonian physics, true process laws have yet to be discovered in the social sciences. Applying a law that ignores time to a market that is constantly moving results in a structural failure. Determining exactly how your model interacts with time is the first step toward building a valid theory. Beyond the timeline, we have to look at how a theory is built. Scientific theories function as architectural structures, resting on a strict hierarchy of laws. The foundational layer consists of axioms, or fundamental laws. These core premises provide support for every other claim. Resting on that foundation are derivative laws, or theorems. These are the specific logical conclusions deduced directly from those axioms. The final layer is the bridge law. This mechanism translates an abstract theoretical idea into a testable reality. We see this in Hunt's 1970 study on cognitive dissonance. The theory suggests that humans feel internal tension when their beliefs conflict. To turn that abstract psychological tension into something a researcher could see, Hunt needed a bridge. That bridge was the concept of post-purchase anxiety. By measuring how uneasy consumers felt after buying a large appliance, like a washing machine, the abstract theory was finally grounded in observable behavior. Without these specific bridge laws, a theory remains isolated in abstraction, untestable, and practically useless for understanding the real world. Once a theory is bridged to reality, we must define its extension. This determines exactly how far a net the law casts across different situations. At the narrowest level are singular statements, tied to a specific time and place, and existential statements, which simply note that a phenomenon exists without claiming it happens everywhere. Most marketing research relies on statistical laws. These are laws of tendency and probability. In the social sciences, variables usually move together as a trend, rather than in mechanical lockstep. This contrasts with strictly universal laws, the claim that all A are always B. In the study of markets, these types of universal certainties are virtually non-existent. Misidentifying a statistical tendency as a universal truth is a fatal error in scope. It produces a rigid, inflexible model that breaks the moment it encounters the complexity of actual consumer behavior. To see what happens when these boundaries are ignored, we can look at the psychophysics of prices controversy, a case where researchers tried to force a physical law into a marketing context. The researchers took Weber's law, a formula designed to measure how the human body perceives physical weight or light, and applied it directly to consumer pricing. The first flaw was in the stimulus itself. They replaced physical sensory inputs, the very thing the law was built to calculate, with abstract cognitive economic symbols. They also changed the focus of the measurement. Weber's law is meant to find the just noticeable difference in a physical sense, but the researchers tried to use it to measure subjective consumer preferences. Finally, they compared the wrong elements. Instead of measuring changes in a single stimulus, they compared price perceptions across completely different brands of gasoline, violating the law's requirement for a consistent baseline. By attempting to use a physics law in a realm it was never intended for, the researchers ignored the original boundaries of the theory. They were using a precision tool for a task it could not logically perform. Scientific laws function as precise instruments with specific limits. Marketing research achieves its predictive power only when researchers define and strictly enforce these absolute boundaries.